Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to talk about the differences between using TCP sockets and UDP sockets in Python. Now, if you want to know more about the theoretical foundations of all that, of sockets, of TCP, of UDP, I have a video called Sockets Simply Explained, where I go into the more theoretical background. So what is TCP, what is UDP, what are sockets, how do they work, and so on. In today's video, we're going to focus more on the implementation details. Now, I'm going to talk about the theory here and there maybe, but in general, we're going to talk more about the functions, the parameters, and so on. And for that, we're going to build two client-server systems. The first one is going to be a TCP client-server system, and the second one is going to be a UDP client-server system. So we're going to just have a server that waits for clients to connect, and then they exchange a couple of messages, and then that's basically it. So we're going to start with a TCP client-server system. For that, I created a file TCP server already, and in that file, we're going to start by importing socket, and we're going to create the first server socket. So we're going to say server equals socket.socket. This is the constructor. And to this constructor, we now have to pass two parameters. The first one is the type of socket. So do we want to use an internet socket? Do we want to use a Bluetooth socket, an infrared socket, and so on, a Unix socket? Basically, we say socket dot and then AF underscore, and then you can see all types of sockets that we have here. So we have iNet for IP version 4, we have iNet 6 for IP version 6, we have, Bluetooth here if you want. I think we should also have some infrared type of thing. However, we want to choose obviously the internet socket, so AF underscore iNet, and then we can, with a second parameter, determine the type of internet socket we have, the protocol that we use. In this case, we're going to use TCP first, so we want to use the connection-oriented protocol, because what we do when we create these sockets is we pass a parameter that tells us, or with which we choose, if we want to use a connection-oriented or a connection-less protocol. Connection-oriented basically means that we have a connection, we establish a connection between client and server, and then this connection is used to exchange information, whereas connection-less means that we send and receive individual messages without having an overall connection. And of course, TCP is connection-oriented. Because of that, we're going to pass socket.sock_stream. And the alternative to that is a connection-less protocol, a datagram-oriented protocol, which would be sock_dgram. We're going to talk about that as well. So when we have that, we're going to say server.listen, because we want to listen for incoming connections. And then we're going to just accept all of them by saying while true. And we are going to call the server.accept function. And this function returns two things. First of all, it returns a socket, another socket, a new socket that is used to communicate with the client. And then it also returns the address of the client that tried to connect, and it is now connected to the server. Now, why do we need an additional socket? Because this server socket here is only used to accept connections. If we want to communicate with the individual clients, we're not going to use that socket. We're going to use the client socket that is returned by the accept function. So client address is going to be server accept, and then we can print onto the command line connected to, and we can connect, we're connected to the address. Of course, we need an F string here. And then what we can do is we can receive messages, we can send messages. Now keep in mind that if the server is trying to receive a message, the client has to be trying to send a message. If both systems try to receive or to send, we're going to have a sort of deadlock situation, because nothing is going to happen. Both are going to wait for the other side to do the opposite of what they're actually doing. So because of that, we're going to say that the server is going to receive first, because the client is going to say hello server. Then the server is going to accept that message. It's going to say hello client. Then they're both going to say bye. And that's the simple example that we're going to use for the TCP client server system. So we're going to say print, and what we want to print is the message that the client sent to us. So we're going to say client.receive, and we can receive 1024 bytes. Now this is the buffer size. For TCP, this parameter is not as important as it is for UDP. Why? Because in TCP, if you choose, for example, to just receive 1 byte, the information is not going to be lost. So you can, if for example, I try to transmit the word hello, or the sentence or the phrase hello world, and I just accept 1 byte, I'm going to read this 1 byte here, and the rest is still going to be stored. So the next time I call the receive function, I'm going to get the rest of the message. And with UDP, that's not the case. If with UDP I choose to receive just 1 byte and the message has more than 1 byte, it's going to drop the message. It's not going to accept it. So for TCP, that is not the most important parameter. Of course, you should pick something that makes sense in your particular context, but this is a very good, a usual number that is chosen. So when we receive that, we get a byte stream. If we want to print that byte stream, we want to decode it. Now we can set a decoding method. So for example, UTF-8. And of course, when you decode with that, you can also choose ASCII, for example. When you decode with a certain method, you should also encode with the same method. So the client has to encode and the server has to decode with the same method. Once we have that, we can send something back. So we can say client send, and we can say hello client. And of course, we have to encode it because hello client is a string, and we want to encode this with UTF-8. And now we can copy that and do it 1 more time. So we're going to receive a message again, and we're going to send bye in the end. And don't forget when the connection is done, since we're having a connection-oriented protocol here. So we have a connection and we send and receive all the time until the connection is closed. So we have to close in the end the connection. So client.close. Now in this case, since this is not multi-threaded, of course, we're only going to be able to handle 1 client at a time, but it's easy to just rewrite that by putting that into a function and then calling a thread or creating a thread that has a target function. If you want to see an example for that, just go to my chat video tutorials, so videos where I have implemented TCP chats. Now let's go to the client. Let's create a client file, TCP_client. Here we're going to just say import socket, and we're going to create a socket here as well. So socket, or actually not socket, client equals socket.socket. Oh, I forgot one thing, by the way. We need to bind the socket. So when I have a server here, I have to bind it to a certain IP address. So I have to bind it to localhost. In this case, if I want to do it on the same computer, and I have to pass a port here. So essentially, when you want to listen, so when you want to accept connections, you have to bind the server to a certain address. So you pass a tuple of IP and port. In this case, I pass localhost because it's running on my computer. If you're running this on a web server, you have to bind it to the local IP address that you can find with ipconfig or ifconfig, depending on the operating system. And you have to connect to the public IP address. So you have to connect to the public IP address, but you bind and host on the local IP address. But for this example here, since we're doing everything on localhost, it doesn't matter. We can always use localhost, and we're going to pick a port number that is probably not used. So then we're going to create a client socket. Again, this is going to be an internet socket, and it's going to be a sock stream socket, so a connection-oriented TCP socket. And now the client doesn't have to bind to the IP address. The client has to connect to the IP address. So we connect to the tuple of 127.0.0.1, port 9999. And this is the difference. So the server binds to the IP address, the client connects to the IP address, and then when the client tries to connect, what happens is the server accepts and this thing here is started. So first of all, the server is waiting for a message, and because of that, as a client, we need to send a message. We're going to say client send hello server. We're going to encode this, of course, with UTF-8. Then we're going to print from the client side here, client.receive. We're going to receive 1024 bytes. We're going to decode this using UTF-8. Now we're going to copy that, and we're going to change this message here to bye as well. So that's a very simple example. Let's run this. We're going to open up the CMD command line here. We're going to open up another CMD command line here. I'm going to navigate to the directory. In this case, it should be neural dir. So I have shortcuts. You can just go change directory and the path. And I have it here as well. And then I can just say TCP client py and TCP server py. I'm going to start the server first. Then I'm going to connect with a client. And you can see hello client, bye, hello server by, and we can see that we are connected to the client. So this is how you build a simple client-server architecture with TCP. Now we're going to do the same thing with UDP, and for that we're going to create a new Python file. We're going to call this UDP server, and here we're going to import socket again. We're going to create a server socket again, socket AFINet, because it's still going to be an internet socket. And then we're going to pass as a second parameter here now socket.sock_dgram for datagram, for a connection-less protocol instead of the connection-oriented sockstream protocol. And in the context of the internet socket, this means that we're going to use UDP instead of TCP. And that again means that we don't have a connection anymore. So we're not going to have a client and a server having a connection and exchanging messages via that connection. We're going to have a server running and a client sending messages to that server, independent messages. So they're not going to be packaged. They're not going to be dependent on each other. They're not going to have any relation. We're just going to send individual messages to the server, and the server is going to receive individual messages. So we still need to bind the server to the IP address. So we still need to say be on localhost, and we still need to pass the port, but we're now not going to call the listen function or the accept function because we're not listening for connections. We're not accepting connections. We're just listening for messages coming in. And because of that, we're going to use the server.receive_from function. So not receive, but receive from. We can still also receive. We can still call just receive, but then we don't know who this is coming from. Remember, we don't have a connection. So when a client sends something to the server, we can still use receive to receive the message, but we don't know who this message is from. So we cannot send anything back. With receive from, we also get the address. So here we pass a buffer size again. Remember, the important thing is that for UDP, if you don't have enough if the buffer size that you choose is not enough to store the full message, you're not going to have, it's going to drop the message. So the return value here is going to be the message and the address of the other socket that is sending the message. And then, of course, we can just go ahead and say print message.decode UTF-8. Now we can just send back a message now using the send_to function. This is the next UDP function. Instead of send, we have send_to because remember, we don't have one client that we're talking to. We have a general function that we can send messages, but we need to specify where we are sending these messages. And for that, we're going to say server.send_to, and we're going to send to the address whatever we want to send. So we're going to say hello client .encode with UTF-8, and we're going to send this to the address that we got from receive from. Now we can also pass just manually a tuple here if we want to, but this is the address that this message is coming from, and because of that we can answer to that address. That's basically it for the server. The client is quite similar, so we're going to create a new file here, UDP client. And here we're also going to import socket. We're going to say client equals socket, and again, socket internet socket, and socket dgram for datagram. And then we can just start by sending. So we can say client.send_to hello server. We're going to encode this using UTF-8. And we're going to send this to 127.0.0.1 at the port 9999. So instead of connecting to that address, we send each message to that address. So we have to specify for each message where we are sending it because it's not part of a connection. We're sending this one message. And of course, what we can do now is we can basically say just print client.receive_from. We're going to receive from the server 1024 bytes after that. Now, the important thing is that, remember, we get two values here. We get the message and the person that is sending this, so the socket from which this message is coming. And because of that, we want to have only the message. We're going to get index 0 here because this is a tuple. And then we're going to decode that using UTF-8. There you go. That should actually be it. Let's see if it works. So if we open up these two command lines again And this time we're going to run the UDP server first. And okay, I think I need to close this and open up a new command line. And we're going to say UDP. Don't I have a UDP client? I should have. Oh, I created it in the wrong directory. So let me just move that real quick. There you go. So now let's go ahead. UDP client. There you go. Let me just show the server as well again. And when I run this, you can see hello server, hello client. This is how it works. Now let me show you what happens with the TCP client if I change the buffer size. So for the server, for example, if I say I will receive not that many bytes, but just 1 byte, what happens then is that, let me just show you. If I run the server, TCP server here and TCP client here, you can see that it gets H and it gets hello server as the next point. It doesn't print the bye message anymore. However, if I were to print another receive or to call another receive, it would also receive that message. But as you can see, if I just accept 1 byte, it's going to get that 1 byte from the client message actually. So this 1 byte is going to be received and the rest is still going to be part of the connection. So it's not lost. With TCP, we don't lose anything. If I do the same thing for UDP, you're going to see a difference here. So if I say in the server, we're going to receive 1 byte, not 1024 bytes. I think I need to restart that again because I have a while loop in there. If I now go ahead and say UDP server and UDP client, you can see I get the exception OS error. A message sent on a datagram socket was larger than the internal message buffer and so on. So it doesn't work with UDP. With UDP, you have to choose the right size, a proper size that is enough. If you fail to do that, you're not going to be able to receive or send any messages. So that's it for today's video. Hope you enjoyed and hope you'll learn something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.